So during the regular screencast, I skipped over practice 14. One of your homework problems, I believe, is 16.54. So if you had difficulty with that one, it may help to kind of see me work through this one. So it gives you this chemical reaction, and it says, for each of the following mixtures of reactants and products, predict the direction in which the reactions will shift in order to reach equilibrium. And so this is really important. If they're asking you which way it's going to shift, then that means that A, B, and C may or may not be at equilibrium. And so if you're not at equilibrium, that's when you want to use the full equation with ln Q, right? Because it's only at equilibrium that delta G goes to 0. So we don't want to simplify this reaction until we know that we are indeed at equilibrium. Well, in order to know which way you need to shift, if you think back, we've got to compare Q to K, right? And if Q is greater than K, then that means we need to shift left. If Q is less than K, that means we need to shift to the right. And if Q is equal to K, then that means we are indeed at equilibrium. And so all we have here are concentrations that'll help us find a Q. So if we look at this, we need to know what's missing. So we need to find a delta G naught. That's going to come from tables, right? We've got a pretty simple little reaction there. R is just a constant. Temperature they gave me is 298, and then Q we'll find for each of the scenarios. So to find delta G naught, I need to do products minus reactants. And so I go and I look up N2O4 gas, and N2O4 gas is 98. And then I'm going to do minus the reactants, 2 times 52. So delta G naught is negative 6. And so negative 6 kilojoules. So like I said, these are going to let us find a Q, but the only way we'll know which way we need to shift is if we know a K. And so remember that at equilibrium, delta G naught equals negative RT ln K. So we can set this equal to negative 0.008314 times 298 times ln K. Take this to the other side, and we get 2.42 equals ln K. So K equals 11. So for A, B, and C, we're going to calculate our Q and then compare it to K to see which way we're going to shift. So all that had to be done before you can even do A, B, and C. Alright, so for A, our Q is 1.0 over 1.0 squared, so that equals 1.0. 1 is obviously less than 11, so Q is less than K. So this one would need to shift to the right to reach equilibrium. For B, Q equals products over reactants, so 0.50 over 0.21 squared, and that comes out to 11. So Q is equal to K, so that means we're at equilibrium, so no shift. And then for C, Q is equal to 1.6 on top, 0.29, and that gets squared on the bottom. We get 19. So Q is greater than K, so we would need to shift to the left to reach equilibrium.